and this is my lab report for Lab 2, Lines of Charge. The purpose of this lab was to use charge tape to compare a point charge and line charge model by dividing the tape into infinitesimal segments to obtain a better approximation of the charge on each tape. This is essentially an expansion on Lab 1, but more accurate results will be obtained due to the use of a better approximation. The concepts that need to be understood are first, Newton's second law, which states that net force equals mass times acceleration. We should then understand Coulomb's law, which allows for the determination of the charges. And then we should understand F equals mg, as the experiment deals with objects with mass. And then finally, the idea of superposition, where the net electric field can be found by summing up the individual electric fields at a point. For the preview of the new results of the lab, I found that the force of electricity is equal to the force of gravity, and this equals 1.932 times 10 to the negative 3 newtons, or approximately. I also found that the charge on each tape is approximately 2.173351 times 10 to the negative 8. This information then shows that the line charge model is more accurate than the point charge model, as with the new charge, the force of gravity and the force of electricity are equal to each other. The measurements, system, and surroundings and assumptions are mostly the same as Lab 1, those being the tape's length at 0.197 meters, the width at 0.02 meters, and the mass at 1.97 times 10 to the negative 4 kilograms, while the separation between the tapes was 0.02 meters. Then the system consists of the two tapes, while the surrounding was everything else in the room. And finally, the assumptions were air resistance being negligible, each tape containing the same charge, but one thing that changed in the assumptions was that each tape was assumed to have an evenly distributed charge as opposed to a concentrated point charge. The procedure of the lab didn't change from Lab 1. A tape was stuck to a table, had a tape stuck on top of it, and was ripped off. It was then hung next to various objects to determine a charge. The tapes were then observed to repel, and the separation was measured. The observations also didn't change, as the lab was attracted to the neutral and negative objects while repelling the other tape, so the tape was determined to be positively charged. For the code, I began by defining constants such as the coefficient of gravity. I also included the measurements for the tape, and then Q was set to a value so that electric force would equal gravity. But initially it was set to the Q found from Lab 1. This will be shown later. I then defined my function for the electric field and line of charge. Then, nearing the bottom of the page, I created my objects for the top and bottom tape. The nested for loops can then be seen at the bottom of the page and the top of the next one, and these demonstrate the superposition of the electric fields. This is the result from the GloveScript model. The first image represents the point charge from Lab 1, and the second image is using the new charge. The white represents the electric force, the yellow represents the gravitational force, the green represents the electric field, the red represents the top tape, and the blue represents the bottom tape. From this, the new Q value of 2.173351 times 10 to the negative 8 coulombs is shown to be more accurate than the result obtained from Lab 1, as the new charge allows for an electric force that balances out the gravitational force. The calculations that went into determining that are shown here, as first the force of gravity was calculated through F equals mg, then electric force was determined as Fe equals Fg, then Q was calculated through setting mg equal to kq over r squared r hat. So some places for error could be in handling of the tape as the tapes discharge on contact, and with that the charges on the tape may not have been exactly equal. The question then asks, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charges. As shown, the charge with a point charge model was 9.268 times 10 to the negative 9, while the line charge showed a charge of 2.173351 times 10 to the negative 8. This difference in model showed a 134.5% increase in coulombs. It then asks why these estimates differ, and that's because of the differing levels of precision. The charges on a line charge are spread out along the tape as opposed to being concentrated on a single point, resulting in varying electric field calculations. This ends up being more precise than the point charge model, as it is a more real representation of the distribution in charge. So a main conclusion from this lab is that a line model offers a more precise depiction of the electric field around real-world objects and can be used to obtain more accurate measurements of electric field and electric force as compared to a point charge model.